In this problem, we're asked to rewrite this linear combination of cosine and sine as a single cosine function with a phase displacement in degrees. And so right away what I've done is I have graphed the function negative 12 cosine, the function 8 sine, and then I graphed when I take y1 minus y2, so the cosine function minus the sine function. So looking at the graph, this black function here is what I end up getting when I subtract the blue minus the red. And we can see it's just another regular old sinusoid, and so we can rewrite the equation of the difference of these two as a single cosine function. So I'm going to go ahead and turn off the graphs of the cosine and the sine graph so it's a little less to look at. And so we're trying to write the equation of this graph here. And so we learned in class that to find the amplitude of the single cosine function, we're going to use the amplitudes of the linear combination. And so cosine corresponds to the x value, which is negative. Sine corresponds to the y value, which is also negative. So that tells me I'm going to draw my angle down into the third quadrant where both sine and cosine are negative. From here I'm going to label my lengths of my triangle, where the negative 12 corresponds to the x value, and then the negative 8 corresponds to the y value. So that'd be right here. So what we found out in class is that the amplitude of my transformed function is going to correspond to the hypotenuse or the radius. And so we will use Pythagorean theorem to then find this number here. So we'll have negative 8 squared plus negative 12 squared, and that will equal my amplitude squared. And so we will have 64 plus 144, so we will end up with 208 will equal my amplitude squared, square root both sides, and I get my amplitude to be the square root of 208. So from here, I now need to find the phase displacement. And so to find this phase displacement, we are going to find the measure of this angle D. And so I can start by doing this by taking the tangent inverse of negative 8 over negative 12. And so making sure we are in degree mode, I'm going to take the tangent inverse of negative 8 divided by negative 12. And I end up getting 33 degrees. Well, clearly this angle right here is not 33 degrees. That's giving me the angle, the reference angle in the first quadrant. So to find the angle down in the third, I need to add 180 to this answer. And so I will get the angle 213.69 degrees. And that gives me the phase displacement. So again, this is a positive angle. So remember, in the equation, it's the opposite, so we subtract. So my final equation, y equals the square root of 208 times the cosine of theta minus 213.69. One way that you could verify that we've rewritten this linear combination correctly is we could then graph it and make sure that the two graphs will coincide with one another. So we're typing in our new transformed cosine function, hit graph, and you can see that this pink function completely covered the black one, which means that these two are equivalent, so we rewrote it correctly.